In statistics, the Z-score and the empirical rule are fundamental concepts that provide insights into data distribution, particularly in normally distributed datasets. These concepts are not just theoretical. They have practical applications in various fields, from finance to healthcare. This article explores what Z-scores and the empirical rule are, how they work, and how they can be applied in real-world scenarios. A Z-score, also known as a standard score, measures how many standard deviations an individual data point is from the mean of the dataset. The formula for calculating a Z-score is where Z is the Z-score, X is the value of the observation, mu is the mean of the dataset, and sigma is the standard deviation of the dataset. So a Z-score can actually be positive or negative. A positive Z-score means that the data point is above the mean, while a negative Z-score means it's below the mean. Pretty straightforward, right? The empirical rule, which is sometimes called the 68-95-99.7 rule, basically describes how data is spread out in a normal distribution. According to this rule, about 68% of the data falls within one standard deviation of the mean, which is between mu minus sigma and mu plus sigma. Then, about 95% of the data falls within two standard deviations. That's between mu minus 2 sigma and mu plus 2 sigma. And nearly 99.7% of the data falls within 3 standard deviations, so between mu minus 3 sigma and mu plus 3 sigma. Investors actually use Z-scores to assess the risk of stocks. A high Z-score might mean that a stock is potentially overvalued compared to how it's performed historically, while a low Z-score could suggest it's undervalued. Financial analysts also use the empirical rule to predict stock price movements and to assess investment risks based on how prices have behaved in the past. So, in manufacturing, maintaining quality standards is crucial. Companies often use Z-scores to analyze product measurements. If a product's measurement has a Z-score beyond plus or minus 3, it might indicate a defect. The empirical rule helps quality control managers understand the expected variability in product dimensions, allowing them to make informed decisions about production processes. So, in healthcare, Z-scores can actually help interpret patient test results. For instance, a Z-score can indicate how a patient's blood pressure compares to the average population. The empirical rule can provide insights into the normal range of vital signs, helping healthcare professionals identify patients who may require further assessment or intervention. Educators often use Z-scores to evaluate student performance on standardized tests. By calculating the Z-scores for test scores, educators can identify students who are significantly above or below average. This can guide interventions or enrichment opportunities. The empirical rule can help schools understand how student performance typically varies, aiding in curriculum adjustments. Coaches and sports analysts use Z-scores to evaluate player performance statistics. For example, a player's batting average in baseball can be standardized using Z-scores to compare performance across different contexts. The empirical rule can help teams understand the distribution of player performance, guiding recruitment and training strategies. Z-scores and the empirical rule are powerful statistical tools that provide meaningful insights across various fields. By understanding how to calculate Z-scores and applying the empirical rule, professionals can make data-driven decisions that enhance performance, maintain quality, and improve outcomes. Whether in finance, healthcare, manufacturing, education, or sports, these statistical concepts can unlock valuable insights and drive better decision-making in the real world.